Low Earth orbit (LEO) has become the hottest piece of infrastructure on and off the planet, and 2025 to 26 is when the money really started to pour in. More than $45 billion was invested in the LEO sector in 2025, up from under $25 billion the year before, as tech giants race to own the layer of space 500 to 2,000 kilometers up that promises low latency, global reach, and a new place to put compute. The bet isn't just on more satellites for broadband. It's on turning orbit into a platform for data centers, AI, and services that used to live on the ground. The scale is staggering. SpaceX already operates more than 9,500 Starlink satellites and is expanding the network while proposing a solar-powered orbital data center system. Amazon's Project Kuiper, now Amazon LEO, plans 3,000+ satellites, with FCC approval for an additional 4,500, and is building out ground and cloud integration with AWS. Blue Origin is expected to launch more than 5,000 satellites by late 2027. Europe's Eutelsat/OneWeb has a LEO network of 600+ satellites, and China has filed plans for 200,000+ satellites across 14 constellations. The sheer number of filings. SpaceX alone filed for up to a 1 million satellite orbital data center constellation in early 2026, shows how quickly the industry is shifting from connectivity to compute. Why LEO? Physics and economics line up. LEO offers faster response times, 20 to 40 milliseconds latencies versus hundreds of milliseconds from GEO, lower launch costs as reusability improves, and the ability to blanket the planet with coverage that terrestrial fiber can't reach economically. That makes LEO the right place for real-time services. Broadband for the unconnected, backhaul for 5G per 6G, IoT, Earth observation, and increasingly, processing data where it's collected. Moving compute to orbit cuts the need to downlink massive raw datasets, process in space, send down only the results. Nvidia's Jensen Huang captured the mood at GTC 2026. Space computing, the final frontier, has arrived. The next phase is orbital data centers. Multiple players are already running hardware in space. Kepler Communications has raised $233 million plus and is deploying optical relay satellites, 100 gigabits per second links, that can move data between satellites at high speed, exactly the backbone an orbital cloud needs. Axiom Space has put orbital data center nodes on Kepler's constellation and is building ISS-adjacent infrastructure for national security and commercial customers. StarCloud, formerly Lumen Orbit, rebranded, raised another $10 million and filed for an 88,000 satellite constellation designed to process, not just relay, data. It's planning AWS Outposts hardware in space and routing through laser-linked constellations like Starlink and Kuiper. Even Google is in R&D on Suncatcher, TPU clusters for orbit. The market may be small today, $1.77 billion by 2029 by one estimate, but it's forecast to scale toward $39 billion by 2035, a 67% CAGR, if launch and hardware costs keep falling. The economics still hinge on launch. Current Falcon 9 class costs are $2,700/kg. Parity with terrestrial data centers likely needs less than $100 per kilogram, which is the Starship promise. Hardware also has to survive radiation and last 5 to 7 years. If those curves bend, the pitch is compelling. 13 times more solar energy in orbit, no real estate constraints, and natural cooling via radiation. That's why SpaceX's CFO is talking about a 2026 IPO at a $1.5 trillion valuation to fund orbital data centers, and why Etherflux is pairing power beaming with compute so a satellite can both process and send energy down. Governance is lagging. The FCC is modernizing rules, a 2025 to 26 NPRM, but filings for 1 million satellites arrived before the regulatory framework had a clear orbital data center category. Experts warn that spectrum coordination, debris mitigation, deorbit rules, now tightened to 5 years, and security for space-based compute are urgent. Still, the strategic logic is driving investment. As one CEO put it, orbital access is becoming a strategic asset much like ports, cables, or energy grids on Earth.